All right, there we go. We should be good. So, hello everyone. Connor here from the Gitcoin team. I'm here with Eric, Augusto, and Milton from the Cartesi team, and we're really excited to have you today. So, we just launched the Cartesi DApp incubation program just a week ago, actually, and we're really excited to see what you guys are trying to build. So, before I hand it off, I'm just gonna show you guys really quick. I believe. Can you guys see my screen?
Yep.
Awesome. So I believe most of you should have seen this already, but if not, so this is going to be. There's about 3 weeks left, and this phase of the incubator is really just for applications. So we want to hear your ideas on what you want to build. You don't necessarily need to start building anything yet, and we're going to select 3 teams with the best ideas to go through like a 3-month incubation process where you'll be paid out up to $20K, and you'll set your own milestones. And you'll work as a team to try to create your DApp and really get it into full production. And at the end of the process, we're gonna end it with a Gitcoin grants round with $20K to be distributed to the top 3 teams, along with any community donations on top of that. So if you guys haven't seen, there's a link on the onboarding page and also on the bounty page to actually put in your application. And this will be through a type form. And so there's good, but definitely take your time, try to find some teammates and really put some thought into it because, the more detail you put into your applications, the better. And yeah, at that point, we'll select the best 3 and you'll be full steam ahead into the program. So we should have some time for questions at the end of this session. But I'm really excited to dive into basically an introduction to Cartesi and what it is and what their technology does. So I guess without further ado, let's get started. So Eric, do you want to say anything before we hand it off to Augusto?
Sure. Thanks, Connor. Hello, everyone. It's a real pleasure to be here with you. We are quite excited to be launching this program because, the Cartesi CK has been out there for a little while, and you guys are going to be the pioneers, the first, let's say, astronauts flying on this ship, and it's quite an interesting moment for us, and also being here to give you all the support, all the attention that you deserve. So we are really excited to see what you guys are coming up with and totally open to receive new ideas. So Augusto is going to be giving you a full tour on the concepts of Cartesi, behind the cards as well. And at the end, we are going to open the session for Q&A. So please don't hesitate to bring your questions. We are all here to help you and clarify as much as possible. So yeah, let's go forward. And without further ado, I'll pass the mic to Augusto.
Thanks. I'd like first to thank the Gitcoin team for this partnership, for launching the program. As Eric said, it's really exciting for us to be launching something that people actually engage more directly with us and build something awesome with the technology we've been building for 2 years now. So it's really exciting to finally deliver something that is nice to work with. So it's a nice SDK, and Milton is going to talk about the SDK in detail the next presentation, but I'm going to focus on what the project is, the long-term vision, and what's available now. So what this SDK does in terms of potential, but not digging so much into the details on how to do it. So how to do it will be left for Milton later, a hands-on approach. So I'll talk about Cartesi first as a company, and then the vision, what is ready already, what we can build now with Cartesi, and then I'll dig into examples, like what are potentially nice ideas that we definitely would like to develop ourselves if we had the energy. We are very focused on the technology itself, but sometimes we see, oh, this would be so nice if someone could implement. So this is why we're so excited. So I'm Augusto Teixeira. I work as CSO at Cartesi. So I design algorithms. I write papers on Medium and some academic stuff as well concerning the technology. And of course, it's a startup, so I do a bit of everything, a lot of code review. And I'm here to give these 3 points. So the vision, what will be possible to do with Cartesi, what's currently possible to do with Cartesi, that's what we call Descartes, this SDK that we have implemented already, and the ideas for applications. So first, let's talk a bit about Ethereum's evolution, which is introducing smart contracts to blockchains. So most of you are familiar with the concept of smart contracts or how you can even code with them. But one of the main objectives of Cartesi is to make the dealing with smart contracts be less of a niche thing. So we believe that after our vision is fully implemented, developers that are not particularly familiar with smart contracts will be able to code for blockchain. This is already half possible. One still needs to program a little bit on smart contracts to use Cartesi, but much less than if you're doing an application without us. So, but we first like to review a bit what smart contracts are in terms of its advantage and disadvantage. So, first of all, a very nice thing about smart contracts is that this is logic that is part of the consensus in the main chain. So if I write a smart contract that contains some token allocation or some non-fungible token allocation, or maybe that does some DeFi logic inside, this is going to be enforced very strongly because only logic that has been confirmed by the underlying consensus is going to last. So for the consensus to be possible, all the logic inside has to be reproducible. So when we write a smart contract in Solidity, compile it to the EVM, every little operation that the machine is doing can be reproduced in different architectures. So if I run an EVM code on my Intel laptop or in a AMD chip or in some ARM, it's always going to give the same result. So this reproducibility is very important for consensus. Another important fact about smart contracts that's often overlooked or spoken little about is the fact that it introduces a permanent API. So when Google creates an API for Google Maps and some developer decides to develop on top of this API, they are running the risk that Google will just make this API deprecated soon. So they will lose all the work they've done. And that actually happens a lot. So this is something that people have to predict and worry about all the time. But when you create, for example, Uniswap, and you have this API that controls the exchange of tokens in smart contracts, if I build a smart contract based on this API, I know that this API will be available forever. So this is a very solid point for intertwining the different applications in the long run. But all that comes at a cost, a very heavy cost. So the fact that it's part of the consensus can be seen as an advantage, but also a big disadvantage because it's very heavy, it's very costly. If you have thousands of nodes running the same computation, it becomes prohibitively expensive at some point. Not only it's not good from the design of the running process, several people having to replicate the same thing again, but even worse, you have to compete in a bid to make your transaction go into the block. So this becomes very heavy very soon. Even if miners could in principle run more code on that moment, the fact that people are buying for space on the block makes it very expensive. Not only running is expensive, but if you store anything on the smart contract, especially in the current design, it makes it available forever. And this has a cost for miners that is passed to the user. So all the things that you want to store in this smart contract becomes very expensive. Currently, it's around $5 to store a single word of 32 bytes. So that's crazy expensive. Besides this scalability issue that we have on smart contracts, it has another problem of being too low level. So it's almost like, although Solidity is a high level language, it's very close to assembly if you look into it. It's very close to the machine. The reason being that it's so expensive to run computations on smart contracts that you cannot have the luxury of having several layers of protection. So you're dealing with price and money of other people in a very low level. Any mistake you make, any stack overflow, any out of bounds array access blows things up and people lose money. And you can't afford to have other layers of protection underneath your code. Not only that, but the fact that we are dealing with a very specific virtual machine, the EVM, makes the tooling very mature. So Solidity and Truff are great projects, but they are very young. And whoever has already coded in Solidity, and I have done quite a bit of Solidity coding, knows that it's very, very mature, and it's a great project, but it's a pain to work with. Some of the errors you see in Solidity are things that belong to computer science in the 70s, not in 2020. And not only that, everything that happens in a smart contract is public, so you have a privacy issue that you have to go around some way or another. So in a nutshell, a smart contract can be seen as a black box where transactions come in from users, and it can implement logic from the outside. It can make transfers, it can change its internal state, and it can call other black boxes. That's why the API is so interesting. And what Cartesi brings to the table is a very strong analog to this smart contract. You can call this, for example, Cartesi smart contract. It has a different way to operate. It has different trade-offs. So let's, of course, start with the advantages. So why would be willing to code on a different type of smart contract, which are these Cartesi smart contracts? So the consensus is not part of the protocol, which again has advantages and disadvantages, but at least it's enforceable. So if someone claims an illegal result for a computation inside the Cartesian machine, inside a contract like this, they are not going to be immediately caught by the underlying consensus layer. Actually, it's going to be a challenge that will trigger the correction of this wrongfully claimed result. So if someone claims a wrong result, there will be someone else who will perform the same computation, say, no, this is not right, and will raise a challenge, and the thing will be fixed in a few transactions. It's not immediate. But what we can guarantee is first that it's reproducible, just as in the case of normal smart contracts, and the resolution of disputes is extremely efficient. So even if your smart contract in Cartesi is running trillions of computations, the dispute resolution on chain takes very few steps. You don't have to reproduce all these trillions of computations on chain. We have an algorithm that we implement to exponentially accelerate the dispute resolution. So in fact, only a few transactions on chain can first determine who was dishonest and also penalize economically who claimed the false result. So this, up to now, is a very strong type of guarantee, but this is not what the biggest advantage of Cartesi smart contracts are, because these guarantees normal smart contracts also have. So let's go on. It also has permanent APIs, the same way as normal smart contracts. And now the things start to change quite abruptly. First, you're not dealing with an EVM inside the machine. You're running a full Linux operating system inside. So things that you run inside are not code that you compiled from Solidity to EVM, but code that you compiled in any language like Ruby, Rust, C++, Python, and you compile it to Linux, and then you can run it inside the machine. So this is already a very big change in terms of tooling. This is a very mature tooling. We call it industry grade because that's what it is. Also, it's very intensive in terms of computation. You can boot a Linux operating system, you can run transactions, trillions of transactions, and still be able to enforce this consensus on the main chain. So this is much closer to what a server would be in a centralized application. So if some people compare the Ethereum ecosystem to some type of decentralized AWS infrastructure, now we are getting an operating system, we're getting a real CPU inside this infrastructure. But before we had something more like a decentralized smart calculator. So the fact that you have Linux and all this computation, and Linux gives you access permissions, file system permissions, execution permissions, all these layers of security are built into your DApp. So for someone to crack a Solidity code, they'll just have to find some way to, jump to the wrong place and mess with your logic. In a Linux environment, people would have to escalate the privilege. So if the attacker is just writing just has the right to send a transaction, this transaction may be received as an SQL string, and you can protect this SQL string from code injection. And even if code injection happens, maybe they, get caught by another system. They don't escalate the privilege to root. So there are many, many layers of protection. That is what actually people implement in the industry to protect applications. This is available to everyone now. The computation is cheap, but also the storage is very cheap, because things that enter in this white box underneath, they don't have to be stored on the main chain. They can be sent in transaction call data or in event logs, and they are fully available for the machine to run and execute without occupying Ethereum storage, which is so expensive and precious. And also, the fact that this black box has code that is not fully written on the blockchain, it's only represented through a hash, a cryptographic hash, makes what's happening inside the box much more private. So we can discuss in more detail later what the privacy guarantees are, but one can start already thinking that there is an automatic layer of privacy that's built in, and one can add more and more layers later on. And of course, there are disadvantages to running this. First, as I already mentioned, the consensus is not immediate. When you send a transaction to a Cartesi smart contract, it's not going to be a claim that is already fully evaluated and agreed upon by the underlying layer of consensus. You have to wait for a few transactions to get this confirmation. We are making this convenient for the DApp developers, but you can expect higher latency for withdrawals, for example. You cannot decide to withdraw something and be able to withdraw it immediately from the contract. You have to wait for people to raise challenge, and then the challenging period to be over. And another disadvantage is that users, in principle, have to run not only an Ethereum node on their machines, but also a Cartesi node. The Cartesi node would do this role of guaranteeing the truthfulness of all the claims on chain. Of course, people don't install Ethereum nodes very often anymore. They often use Infura or some other service that runs an Ethereum node for them remotely. People can also choose to run a Cartesi node remotely. We are developing a kind of Infura for Cartesi so that people don't have to bother about this. So although there's advantage to this new way of coding, we are working very hard to mitigate those, and we can expect this to be production ready very soon. So this is an overview of what Cartesi brings to the table. You want to make smart contracts that run Linux inside, and you can think of them as a server that listens to some port, has Apache or Nginx installed, run some logic in your favorite language, have a Django application running inside, and it writes to another port to make transactions to other smart contracts like this. Everything living inside the blockchain, but at very little cost to the underlying chain. But that's not fully ready yet. So we have a roadmap that will implement everything. What we have now is what we call Descartes, which is the first SDK that we are making available for the community and especially for you. We've made integrations with other with other blockchains. Now we offer not only Ethereum, but Matic and Binance Smart Chain. And we are on our way to publish on mainnet. So we are here somewhere between integrations and mainnet. And I would like to emphasize there is a big step called statefulness that we have to implement before the picture you saw above is fully implemented. This is something we're working very hard on, and we expect to have it delivered by the beginning of next year. But with what we already have, Descartes, it's already possible to do applications that would be completely impossible to do on the main chain without Cartesi. So let's dig a bit into what Descartes is. So Descartes is very similar to what I just mentioned. It's a smart contract that can be thought as a black box that receives transactions from users, and it gives some result after those transactions are processed. This smart contract is running Linux, running any code that you write inside in any of your favorite languages. It's very powerful in terms of computation. You can run simulations, artificial intelligence algorithms, sorting algorithms, anything you run inside, it scales. But there is one big caveat, that's why we don't call it stateful yet, is that this smart contract is a one-shot smart contract. What does that mean? You create a smart contract, you send several transactions, you run it, it processes all the transactions and gives an output, a result. So this is not the full vision yet, because we would like it to be something that always stays alive as a server. So you can send transactions, it sends results, send more transactions, it sends more results. This is not ready yet. But let's see how this simple one-shot smart contract can already be very powerful and can unleash several applications that are not possible yet. So what are the limitations again? It's not stateful. We're working on it. We expect it to be ready by the beginning of next year. It also, another limitation I forgot to mention, it up to now only supports a few validators. So in some contexts, I will explain more about this later, but in some contexts, it's perfectly fine. So you have a two players game or a few players game. Everyone is a validator. Everyone has the full authority to enforce the correctness of the computations. In an application that involves thousands of people, you cannot allow yet all of them to be validators. We are also working on that. We plan to have by the next year an unlimited number of validators. This requires some changes in our code. But for now, we can work with smart contracts that have very few people involved. Imagine a two-players game, for example. Or we can work with smart contracts that have several people involved, but they outsource the validation to some quorum. And we are working with companies to serve as quorum holders for us. So, for example, you could imagine having your smart contract be validated by 6 strong projects, including us, Cartesi, who will be running validator nodes, and other companies that we'll announce later have partnerships and work as validators. And the important guarantees that we give in this quorum setup is that one single company out of this N that you chose for the quorum can alone enforce security. So it's not a voting system. It's not like our validators are trying to agree on some result and they vote and the majority gets to tell the truth. If you have one single company in this quorum that is honest, it can prove all the others wrong and enforce the correct result. And another limitation of Cartesi, of Descartes right now, is not really a limitation of Descartes, it's the limitation of the underlying blockchain that has very heavy transaction costs on users. So that's why I decided to integrate with other chains, currently Matic and Binance Smart Chain, so that the transaction cost of the underlying chain doesn't kill the application people have in mind. So some applications, especially games, for example, they cannot survive in an environment that to play a game you have to pay something like $5. So by going to these other layer solutions like Matic or to some more optimized blockchains like BSC, optimized for different usages, people can bring these transaction costs 3 or 4 orders of magnitude down, and then it becomes very feasible. So let's jump now to the applications I promised. So when we are dealing with something kind of unique, like Cartesi, it's sometimes hard to imagine, like, what could I do with this different tool? Even Ethereum, when I first heard of it back then, I said, okay, this is amazing. We have smart contracts. We can implement logic on chain. I know this is big. It's a big step from Bitcoin that had a very small scripting language that worked on top of the unit. But now having a fully Turing complete smart contract on chain that was thought through during the development, this is big, but what can we actually do with it? So it took me time to digest the idea of what you can do with Ethereum, and actually took me time mostly because I had to see some applications. Like I had to see CryptoKitties, I had to see decentralized exchanges flourishing to understand, oh, this is what you can do. So I want to give the same taste for people who are just hearing about Cartesi, like, okay, I understand this is a Linux environment, whatever, what can I do with it, which is genuinely different from what I could do on Ethereum. And I picked 3 examples, which are quite arbitrary. We have more examples if people want to hear later. But I picked 3 that I find are very representative of what you can do with Cartesi. The first is a strategy game. So people talk about games in blockchains a lot because it adds several different dimensions to the gaming experience. The fact that you can own your assets in form of NFT, first introduced by CryptoKitties, but now used by several other projects. This is big, and these assets could be in-game assets like items, but it can be much more complex, like it could be game logic that could be owned, it could be land that could be owned, and this adds a whole new dimension. And another important thing is modding an API. As I mentioned, the APIs that you embed in your game, if they are on the blockchain, they are permanent, and people feel much more secure to interact and develop on top of this API, knowing that it's permanent. So if you make a game like CryptoKitties, and everyone knows that these NFTs will work the same forever, and you can always transfer them, and have second markets on top of them. If you know that this will be there forever, you can build games on top of CryptoKitties, and this is happening all the time. So the fact that games in blockchain are much more rich and add this new dimension to gaming is a big thing that could not be explored to its full extent yet because it lacked something like Cartesi. So I'm going to pick an example of a game that displays this difference. And then I'll talk about two more projects, an AI outsourcing platform and another game that works quite differently from the previous one, just to give another reason why Cartesi could be an interesting platform to develop upon. Let's start with the strategy game I mentioned. So it's an artificial idea. I'm not saying that this game has been implemented yet. As I said, we have very exciting ideas that we don't have the time to implement because we are developing the infrastructure. But let's imagine something that's much more natural. You develop a game, like a strategy game, where people build a base and they can put walls around their base and different facilities that produce armies that shoot lasers at approaching enemies, and you can develop an elaborate base that's gonna fight against your enemy's base. And this could be a single shot thing, like you prepare your base, send your base to the smart contract. Your adversary prepares the base and send the base to the smart contract. It could also be more interactive. You could like ping pong moves from one player to the other, especially if you are running on Matic, for example, where the cost of transactions is much lower. It's it's a tenth of thousands of a cent. So it's if you're running 10,000 transactions, you can still in the range of 1 cent. So this is quite payable. But let's keep it simple now. You just prepare your base, and your adversary prepares theirs, and you just put these two bases to fight in the same terrain. Okay, this sounds like a very interesting proposal because you could have unique towers to add to your base. So this opens a whole new space for NFTs. You could have these bases and these fightings be on some land. So this opens the whole space for NFTs that represent land. So you're actually conquering land from someone else. Or we could have special logic in our bots that go fight the adversary, or on our towers that defend our base, and we could buy and sell these programs that run on our robots. So there is infinite space to innovate in there. But for this to be really viable on the blockchain, all this complicated logic you can see in the right picture there of a fight taking place and invaders shooting at your towers, this computation has to be done on chain, or at least in some verifiable way. Otherwise, Alice will post a base, Bob will post his, and each of them will claim they won. Who's gonna be the judge of who won? The way Cartesi works is they both do the computation, they post the result. If someone posts a wrong result, this is resolved very efficiently on the blockchain without having to do this whole computation of the war on the consensus layer to determine who's correct. It's something in very few transactions you determine who's correct in a cryptographic way. So this is an example of a game that is very interesting from the perspective of players, because it definitely uses all these new dimensions that blockchain add to games, but can only be done if you can run intensive computations on chain, or at least in an enforceable way. Another important thing, if you want to develop this, you don't want to do this logic of blowing things up and robots and towers on Solidity. If you already played with Solidity a little bit, you know what I'm talking about. You want to do this in your favorite language. C++, Go, I don't know. There are several languages that are much more appropriate to developing a complex logic like this. Maybe you want to use Lua scripts for the towers. Maybe you want to use a very efficient low-level language like C++ for pathfinding or for field of view. You don't want to do this all on Solidity. That would be impractical and essentially kill the whole development process. So that's the first application. Now we're going to switch gears to something completely different. So if you like this example, great, but now it's something completely else. Imagine that Alice has some website or some service, and she wants to do some artificial intelligence application on her website. So maybe she has a tourism website, and she wants to classify pictures from her users, and she doesn't want to, go in the market to hire someone to be full-time working on AI for her. We know that AI professionals are very expensive, and it's a once-time job. She just wants a single program that takes a picture and tells if it's a Baroque thing or Gothic building. I don't know. She wants something simple API, but she knows that developing AI image recognition is something that is very specialized. So she wants to outsource this. So now we are building a platform to allow Alice to meet Bob, the developer of this API. So she will be able to hire him in a trustless way. There's no intermediary, there's no trust. She will hire someone who's skilled in doing neural networks development, and she will be sure that he was able to attain the requested performance on the recognition, and he will be sure that if he actually attains the required performance, he'll get paid. So this is a very simplified diagram, but we have this machine that is going to be our Linux operating system with some code on it. Before, the Linux operating system was running a game verifying logic, right? A simulation of a war game. Now it's doing something completely different. It's running a neural network on a range of pictures and telling which pictures were recognized correctly and which pictures were recognized wrongly, and it will output the performance, like some percentage. So how does she do it? She submits to the blockchain lots of pictures, so her training data set, and everything encrypted so that people cannot just, look at the picture and recognize themselves by just inspection and then write an algorithm that, just spits the right result. So she'll send the pictures, encrypted pictures. And after she sends that, she'll be required to unlock or decrypt randomly half of them. So you can see in the diagram there, the pictures on the left have been revealed, and she did not get to pick which ones would be revealed. And the pictures on the right are still hidden. And also, every picture has a label. So this is a Gothic church. This is a Baroque fountain. So all the pictures are labeled, and now she can, look for someone who wants to pick this job. There definitely has to be some logic to select the worker and deposits for payments. I'm hiding this logic, which is much more similar to what smart contracts can already do. But at some point, she found the perfect guy for the job. Bob knows a lot about neural network. He lives in a country that doesn't have good jobs, good positions for that. So he works as a freelancer on your platform. And he just designed this neural network process that will recognize the pictures for her. So he used the training set that has been revealed to him to train his data, his neural network. He posts the neural network to the smart contract, and then she finally gives the key to reveal all the testing data set, the pictures that have not yet been revealed. And now we can run his neural network on the missing data set and tell if it was good or not, and pay him or not, or pay him dependingly on the performance. Maybe there is a curve to tell how much he should receive for each performance. But in the end, what is possible to do now is outsource some verifiable job. Like this is a job that is very technical, very skilled, but a machine can verify if the job was done correctly or not. So So it's very different, for example, from surgery. Surgery is also a very high skill job, but you cannot build a Linux machine that verifies if a surgery was done correctly or not. But several jobs fall in this category that can be verified automatically by a machine. So we can join this with the logic of payment and looking for people to hire, and we can come up with a job system that avoids intermediaries and is global, is trustless, it's low friction. So I think it has a very big proposal in terms of value. Okay, that was a quite different application. And now let's move to our last one, which again, totally different. It's also a game. So you can think of it as poker, for example, or some Magic the Gathering style game where you have cards and each card has, its function. You don't have to be worried about the logic of the game being complex, because the logic of the game is going to be written in Linux. So you can, have, instead of, knights in simple logics as in chess or as in poker, you can have very complicated dragons that interact with fire, whatever you want to implement it. The logic is not relevant here, but you can think of poker as an example. So poker is a good example because it seems like it's so simple it could be done directly on the blockchain, right? So poker has 5 cards for each player, or depending on the type of poker you're playing, there are 2 cards you get to pick, but it's a few cards. And the logic to determine who won is very simple. Just check if someone has a street flash or 3 same cards. So it's a very simple logic. So it's tempting to say, let me implement this in Solidity, and it's done. The problem here comes from the privacy part. So if we shuffle a deck of cards on Solidity using any logic, and you publish the shuffling, the person knows the cards of everyone. So if I pick the 5 first cards, but everything else in the blockchain, my adversary knows my cards. So there's no poker there. If I cannot hide my cards, I cannot play poker. So the point is that privacy is having a huge impact on the logic and the playability of this game. So how can Cartesi help with that? So people have thought about this a lot since cryptography appeared. Actually, this problem was solved first by the same creators of RSA, the first asymmetric cryptography protocol. So this is a problem that is dear to the hearts of cryptographists, and they have solutions. So it's possible to take a deck of cards, shuffle them in a weird way using cryptography, and distributing the cards in a way that Alice only knows her cards, Bob only knows his cards, everything's safe, they can bet and play. But behind that, there is strong cryptography. There are algorithms that are very unknown, but are very hard to code on Solidity. So the logic is not extremely complicated when you look at the game, but when you look at the zero knowledge behind it that needs to be implemented, it's quite complicated and cannot be done in a Solidity smart contract. But it has been done for Linux. I mean, you have tens of zero knowledge libraries that can implement this shuffling in a cryptographic safe way. And you can run in Haskell, or some are written in C++, Python. So you can use these libraries and implement a poker game. But now you have to be careful that the verification process has to decrypt all the cards and people review by sending cryptographic keys. So it can be done, but only in something, only Cartesi or something very similar to Cartesi. You cannot do this directly on the EVM by practical reasons. So yeah, I think I spoke a lot. I hope you enjoyed. Thank you very much. And I wanted to leave a good time for questions and interactions. I'll be here. Eric will also be here, and Milton. to drive you through both the API, the SDK, and also ideas that we can try to foster in this new environment. Thank you.
Awesome. Thank you so much.
No, I think
No,
it's
let's
good. We're going to be available for a while here to answer to your questions. Thank you, Connor.
thank you.
Social lounge, where is it?
Como que vai?
Where is it? Did you find it?
Should be a league somewhere, right?
Should be behind the video sessions here, but you can't see.
There's an exit button.
Where?
No, that's to exit the whole thing.
Yeah, there's an X. Yeah, not that one.
Então, fica aí que eu vou sair e entrar, tá? I'll try to.
I don't know if people are still watching us. There's one. No.